There is a sentence in the physics literature that by the discipline's own rules should not have been possible to write. Why did Physical Review Letters in 2013 publish a lower bound on the lifetime of a photon, stated in the photon's own rest frame, when every undergraduate is taught that the photon has no rest frame? Where did the energy go when every particle of light left over from the Big Bang lost more than 99% of what it was born with, and nothing absorbed it? And why, in 2018, did a team including Anton Zeilinger and Alan Guth aim telescopes at quasars and use light emitted billions of years before the Earth existed, as the random number generator for an experiment running in a room in the Canary Islands? 3 questions, from 3 unrelated corners of physics that look like they have nothing to do with each other. They have the same answer. It is one number. It has been in the textbook since 1908. Every competing interpretation of quantum mechanics agrees on it without argument. And it is the one thing about light nobody disputes. It is also the thing almost none of them will follow to its conclusion in public. The number is 0. Get comfortable, because by the end of tonight you will understand why the passage of time may not be a property of the universe at all, but a side effect of being made of heavy things. Ad-free versions of these episodes live over on our Patreon, Meridian Labs, which sits behind this channel and a handful of others like it, along with early access before anything goes public. Subscribe or join if you have not. Let's ease into it. On the morning of March 19th, 2008, for about 40 seconds, there was a new star in the constellation Boötes. It was faint, somewhere around magnitude 5.3, which puts it right at the edge of what an unaided human eye can register on a clear night away from city light. If you had been standing outside in the right hemisphere, at the right minute, looking in the right direction, with dark adapted eyes, you would have seen it. There was no telescope involved, no filter, nothing at all between you and it. Just the thing itself, arriving, what you would have been looking at was an explosion that happened 7.5 billion years ago. The universe was less than half its current age. There was no sun. There was no Earth. There was no solar system anywhere near this region of the galaxy, because the material that would eventually condense into the rock you are standing on had not been assembled yet. A star roughly 30 times the mass of the Sun ran out of fuel, its core collapsed, and for a few tens of seconds, it released more energy than the Sun will release across its entire 10 billion year lifetime. SWIFT, the orbiting gamma-ray observatory, caught the burst at 6 hours, 12 minutes and 49 seconds universal time. It was catalogued as GARB 080319b. Astronomers now call it the naked eye burst. Joshua Bloom at Berkeley, who led the first afterglow analysis, described it as the brightest optical and infrared event humanity has ever recorded. NASA put it more bluntly. For nearly a minute, that single dying star was as bright as 10 million galaxies, and the light from it landed in human eyes. Now here is the part that does not get said out loud, in classrooms or in documentaries or in any of the coverage that followed. From the light's own accounting, that journey took no time at all. Not a short time. Not a compressed or dilated or nearly instantaneous time. 0. The moment that light left the collapsing core of that star and the moment it was absorbed by a molecule of rhodopsin in the back of somebody's eyeball were, along the path the light actually took, separated by nothing whatsoever. No duration, no interval, no elapsed anything of any kind. 7.5 billion years of history unfolded between those two events, as far as everything with mass is concerned. For the light, they were the same event. That is not a metaphor, and it is not a simplification for a general audience. It is a direct consequence of the geometry that Hermann Minkowski wrote down in 1908. It has been in every graduate textbook on relativity for 70 years, and it is not controversial in any corner of physics. What is controversial, or rather what is quietly avoided, is what it means. Because if you ask a physicist about this directly, if you walk up to somebody who works on general relativity and you say, "What does a photon experience on its way here?" you will almost always get the same answer. It is a very clean answer. It goes like this. The question is meaningless. There is no valid reference frame for a photon. The transformation you would need to get into that frame is mathematically undefined. You cannot ask what light experience is because there is no perspective from which to experience anything. Next question, and every part of that answer is technically correct. It is also, and I say this having read a great deal of the pedagogical literature on how relativity gets taught, one of the most efficient conversation-ending moves in all of physics. It is correct in the same way that telling a grieving person that consciousness is a pattern of electrochemical activity is correct. It answers a question nobody asked in order to avoid the one they did. Because the thing that survives after you strip away the invalid frame, after you throw out the photon's point of view, after you concede every technical objection, is not nothing. What survives is a number, and the number is 0, and it is the same 0 in every reference frame in the universe. It does not depend on perspective. It is not an artifact of how you set up your coordinates. It is what the geometry of spacetime says about the separation between the star that died and the eye that caught it. I want to be precise about the thing that is going to run underneath this entire story, because everything else builds on it. In relativity, the fundamental quantity is not distance and it is not duration. Both of those are perspective dependent. Two observers moving relative to each other will disagree about how far apart two events were, and they will disagree about how much time passed between them, and both of them will be right. What they will not disagree about is a combination of the two. Take the spatial separation, square it. Take the time separation, multiply by the speed of light, square that. Subtract. What you get is called the space-time interval, and every observer in the universe, regardless of how they are moving, calculates the same value for it. It is the closest thing physics has to an absolute. For anything with mass, that interval is negative in the standard convention, and the square root of it, divided by the speed of light, is the proper time. That is the time a clock actually reads if it travels along that path. Your wristwatch measures the proper time along your world line. So does every atom in your body. So does the decay rate of the carbon in your bones. For light, the interval is 0. Exactly 0. Not close to 0, not 0 in the limit, not 0 to within experimental precision. The spatial separation and the temporal separation cancel each other perfectly, by construction, because that is what moving at the speed of light means. Physicists call these paths null. It is a strange word for it. Null, as in void, as in empty, as in nothing there, and because proper time is derived directly from that interval, the proper time along any path that light takes is 0. In every frame. Always, without exception. That star died. Its light crossed 7.5 billion years of expanding space. It went into somebody's eye, and the geometry of the universe records the separation between those two events as nothing whatsoever. Here is the question that has been sitting underneath that fact for 117 years, and it is the question this entire thing is going to be about. If nothing happened to the light, what exactly did the happening? Something clearly happened. 7.5 billion years of it. Galaxies formed and collided. The solar system condensed out of a molecular cloud. Life appeared on at least one planet and spent 4 billion years reorganizing itself until some of it built a satellite capable of detecting gamma rays and put it in orbit. All of that happened in what we would call the interval between the emission and the absorption. But the thing that connected those two events, the actual physical entity that made the connection, logged none of it. Its entire existence, from birth in a collapsing stellar core to death in a retina, was a single undivided instant with no inside. So who is right, the clocks or the light? And the standard answer, the one you get in a lecture hall, is that this is a false dichotomy, that both descriptions are valid, that time is relative, and everybody's measurements are equally real. Which is true, and which is also the sort of answer that lets you leave the room without thinking about it again. I do not think you get to leave the room. Because there is a version of this question that is not a matter of interpretation at all, and it is a version that almost nobody puts in front of a general audience, and it goes like this. Proper time requires rest mass. That is not philosophy. That is what the equations say. A clock is a physical system that changes state at a regular rate, and every such system, every single one, without exception, is built out of things that have mass. Massless particles do not have a rest frame, they do not tick, they cannot be used to build an oscillator, they have no internal degrees of freedom that evolve along their own path. Duration is not a property of the universe that gets handed out to everything in it. It is a property that emerges for the specific subset of things that happen to be heavy. Hold on to that. It is going to come back, and when it does, it is going to arrive with the entire history of the universe attached to it. Because the universe is not mostly heavy. The universe is overwhelmingly, almost entirely, made of the other thing. But before any of that, I want to go back to 1908, to a lecture hall in Cologne, and to a mathematician with about 4 months left to live. Hermann Minkowski was 43 years old in September of 1908, and he was already one of the more respected mathematicians in Germany. He had held chairs at Königsberg, at Zurich, and at Göttingen, which at that point was the mathematical centre of the world. He had done serious original work in number theory and in the geometry of numbers. And on the 21st of September, he stood up at the 80th Assembly of German Natural Scientists and Physicians in Cologne and gave a talk called Raum und Zeit. Space and time. He opened it with a sentence that is still quoted more than a century later, and he opened with it deliberately, because he knew exactly what he was doing. The views of space and time which I wish to lay before you, he said, have sprung from the soil of experimental physics, and therein lies their strength. They are radical. Henceforth space by itself, and time by itself, are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality. That is a mathematician announcing the abolition of time as a separate thing. In a lecture hall. To a room of physicians and natural scientists. In 1908, what Minkowski had realised was that Einstein's special relativity, published 3 years earlier, was not really a theory about clocks and rulers and moving trains. All of that was symptom. The actual content was geometric. If you stop thinking of space as a stage and time as a river running past it, and instead treat them as 4 dimensions of a single structure with a particular rule for measuring separation, then every strange result in special relativity stops being strange. Length contraction and time dilation become what they look like from inside a 4-dimensional geometry when you slice it at different angles. They are not effects, they are perspective. And in that geometry, light occupies a specific and very peculiar position. It sits exactly on the boundary between the paths a massive object can take and the paths nothing can take. The cone of null directions. The surface where the interval goes to 0. Minkowski sent the written version of the lecture to the journal Physikalische Zeitschrift just before Christmas, on the 23rd of December 1908. On the 12th of January, 1909, less than 3 weeks later, he died in Göttingen of a ruptured appendix. He was 44 years old. The paper that created Spacetime was published days after the death of the man who wrote it. He never saw what it did. He never saw general relativity, which was built directly on his formalism and would have been essentially impossible without it. He did not live to see any of it, and there is a version of the history of physics where he is a footnote to Einstein instead of the man who told Einstein what his own theory actually meant. And there is one more detail that I find genuinely difficult to sit with. Minkowski had taught Einstein at the Zurich Polytechnic a decade earlier. He remembered him, not fondly. According to Max Born, who heard it from Minkowski directly, his assessment of his former student was that Einstein had been a lazy dog who never bothered about mathematics at all. When the four-dimensional formalism arrived, Einstein returned the compliment. He called it superfluous learnedness. He said, and this is reported by Arnold Sommerfeld, that since the mathematicians had invaded relativity theory, he no longer understood it himself. He thought Minkowski had taken a clean physical insight and dressed it in unnecessary machinery. 4 years later, he was using that machinery to build general relativity, and by 1912, he was describing his own original theory as childish by comparison. I am not telling you this because it is a nice bit of colour. I am telling you because the thing Einstein initially dismissed as superfluous is the exact structure that makes the zero possible. Without Minkowski's geometry, the statement that light experiences no proper time is not even expressible. You need the interval. You need the four-dimensional metric. You need the null cone. The man who handed physics the language in which its strangest fact can be stated died 4 months later of an inflamed appendix at 44, in an era when a course of antibiotics would have had him back at the blackboard in a week. And what his geometry says, once you follow it honestly, is worse than what gets taught. Let me deal with the objection properly, because it is a real objection, and the audience for this deserves the real version rather than a straw man. The objection is that there is no photon frame, and the reason there is no photon frame is not vague or philosophical, it is arithmetic. To transform from your frame into the frame of something moving at velocity v, you multiply by a factor called gamma, which is 1 divided by the square root of 1 minus v squared over c squared. At half the speed of light, gamma is about 1.15, at 90%, about 2.3, at 99.99%, about 70. As v approaches c, the term inside the square root approaches 0, and gamma approaches infinity. At exactly c, the denominator is 0. The transformation is not large, it is not extreme, it does not exist. It is a singular matrix, meaning it maps the entire four-dimensional structure of spacetime onto a degenerate lower-dimensional thing and cannot be inverted. You cannot boost to the speed of light for the same reason you cannot divide by 0. It is not difficult. It is undefined. Missner, Thorne and Wheeler say it. Schutz says it. Carroll says it. Taylor and Wheeler say it in the book most physicists learn this from as undergraduates. There is no rest frame for light. Nothing about that is in dispute, and nothing I say for the next 2 hours should be read as disputing it. But watch what happens when that objection gets used. A student asks what a photon experience is. The correct technical response is that the question presupposes a frame that does not exist. The student, who is not stupid, then says fine, but the proper time along the path is still 0, right? And the standard response to that is usually a slightly irritated yes, and a change of subject. Go look at the physics teaching forums. Go read the threads on this specific question, which recur every single semester, year after year, for decades. What you find is not confusion. what you find is a large number of people with graduate training in relativity saying, in various careful ways, that the standard answer feels like a dodge, and that they are not satisfied by it, and that they suspect there is something real underneath it that the profession has decided not to look at. Because three things are simultaneously true, and physics has gotten very comfortable stating only the first one. The first is that there is no valid inertial frame for a photon. Correct. The second is that the spacetime interval along a null path is exactly 0, and that this is an invariant. It is frame independent. It is not a perspective. It is the same in your frame, in my frame, in the frame of a spacecraft accelerating at 99.9% of light speed through the Boötes void. Everybody agrees. 0. The third is that the limit is perfectly well behaved. Take a massive particle and accelerate it. At 99% of c, the proper time along its journey is about 14% of the coordinate time. At 99.99%, about 1.5%. Keep going, and the proper time along its path goes to 0 smoothly, continuously, with no discontinuity, no anomaly, nothing pathological anywhere along the way. The endpoint frame does not exist. The approach to it is unremarkable. Physics is full of quantities that are defined only in a limit, and nobody refuses to discuss them. The honest statement, the one that survives every technical objection and still says something, is this. There is no experience, because there is no experiencer and no frame in which to have one. But there is also no time, not a small amount of time. None, and that absence is not a feature of any observer's viewpoint, it is a feature of the geometry itself. The popular version smuggles in a subject. It says the photon experiences the trip as instantaneous, which imports a little consciousness riding along on the wavefront, and that version is wrong and deserves to be corrected. The version physics actually supports is stranger, because it removes the subject and leaves the 0 standing there on its own. There is no one inside the light. There is also no duration for anyone to have been inside of. Now hold both of those at once and ask again what connected that dying star to that human eye across 7.5 billion years. And notice that the answer cannot be a journey. A journey requires a traveller and an elapsed time, and the light has neither. But if it is not a journey, then the oldest light in the universe is a much more disturbing object than anyone tells you. And there is a great deal of it. It is passing through your body right now, several hundred quanta per cubic centimetre of you. And it has been doing so continuously for every second you have been alive. In 1964, 2 radio astronomers at Bell Telephone Laboratories in Holmdel, New Jersey, were trying to get rid of a noise. Arno Penzias and Robert Wilson had inherited a 20-foot horn reflector antenna that had been built to bounce signals off the Echo balloon satellites. It was an absurd-looking instrument, a great aluminium horn on a mount, and it was extremely good at what it did, which was collecting faint microwave signals with very low internal noise. They wanted to use it for radio astronomy. To do that, they needed to characterize every source of noise in the system and eliminate it. They eliminated everything they could think of. They accounted for the atmosphere, they accounted for the receiver electronics, they pointed at empty sky and at the galactic plane and compared, and there remained a residual hiss, corresponding to an antenna temperature of about 3.5 degrees above absolute 0, that came from every direction they pointed, at every time of day, in every season, with no variation. They found a pair of pigeons nesting inside the horn. The birds had coated the interior with what Penzias later described, in one of the great euphemisms of 20th century science, as a white dielectric material. They trapped the pigeons, released them elsewhere, and the pigeons flew back. They cleaned the horn. They taped over the rivets. The hiss did not change. 45 kilometers away, at Princeton, Robert Dicke was leading a small group that included Jim Peebles, Peter Roll, and David Wilkinson, and they were building a radiometer specifically to look for the leftover radiation from a hot early universe. They had worked out that if the universe began in a dense hot state, the radiation from that state should still be here, cooled by expansion, filling everything. They were weeks away from switching their instrument on. Then the phone rang. Penzias had been advised to call Dicke about his noise problem. Dicke listened, put the phone down, turned to his team and said, "Boys, we have been scooped." The two papers appeared together in the Astrophysical Journal in 1965. Penzias and Wilson reported an excess antenna temperature at 4,080 megacycles per second. Dicke, Peebles, Roll and Wilkinson explained what it was. In 1978, Penzias and Wilson received the Nobel Prize in Physics. Dicke did not. That is the version that gets told, and it is usually told as a charming story about pigeon droppings and serendipity. The part that gets left out is the part with a body count. Because 16 years before Penzias and Wilson found it, two people had already predicted it, with a number in print. Ralph Alpha was a graduate student working under George Gamow at George Washington University. Robert Herman was a physicist at the Applied Physics Laboratory. In 1948, working through the consequences of a hot early universe, they calculated that the radiation left over from that era should still exist, that it should have cooled as the universe expanded, and that its present temperature should be on the order of 5 degrees above absolute zero. The actual measured value is 2.725 degrees. For a calculation done in 1948 from first principles about the temperature of the universe, that is not a miss. That is one of the more remarkable predictions in the history of the field. Nobody used it. Penzias and Wilson did not know about it. The Princeton group, who were searching for exactly the thing Alpha and Herman had predicted, did not cite them. When the discovery papers were published, the 1948 prediction played no role whatsoever in the interpretation of the signal. It was simply absent. Alpha and Herman spent years afterwards trying to work out how this had happened, and one of the details that Alpha kept returning to was that in the late 40s and early 50s, they had asked radio astronomers whether the radiation could be detected, and had been repeatedly told that it could not. Penzias later remarked to Alpha that with a bolometer it could have been found back then. Alpha's own account of what followed is preserved in his private papers, which his son Victor published in the journal Physics in Perspective in 2012. Before Penzias delivered his Nobel lecture, Alpha spent more than a day with him going through the 1940s history in detail, making sure he understood who had predicted what and when. Penzias gave the lecture. The earliest Alpha and Herman work was still not cited. The one paper of Alpha's that was mentioned was miscited, given the wrong year. Shortly after returning home from that, Ralph Alpha, aged 57, had a heart attack. He received the National Medal of Science in 2005. He died on the 12th of August 2007 at 86. Those who knew him in his later years describe a man who had become bitter and who was, as one account puts it, not at all pleased to have been left out of nearly every telling of the story. And there is a detail in the earlier history that borders on farce. The 1948 paper that made Alpha's name is known universally as the Alpha Beta Gamma paper. Because the author list reads Alpha, Betha, Gamow, Hans Betha did no work on it. Gamow added his name to the paper as a joke, because the three names made the first three letters of the Greek alphabet, and Gamow thought that was funny. Alpha, a graduate student trying to establish a reputation, spent the rest of his life watching his own doctoral work attributed to a Nobel laureate who had not written a word of it. I am not raising this because injustice is entertaining. I am raising it because the pattern is going to repeat in different forms for the rest of this story. And because the specific thing Alpha and Herman predicted is the specific thing I need you to understand next. They predicted the oldest light. And the oldest light is where the zero stops being an abstraction. Here is what the cosmic microwave background actually is, stated with the precision it deserves. For the first few 100,000 years after the Big Bang, the universe was an opaque plasma, free electrons everywhere scattering photons constantly, so that light could not travel any meaningful distance before being deflected. It was hot enough that neutral atoms could not survive. Then the expansion cooled it below the threshold where protons could hold onto electrons, and in a relatively short window, the free electrons were swept up into neutral hydrogen and the fog cleared. The Planck satellite's final data release, published in 2020 by the Planck collaboration, puts that moment at a redshift of 1089.8 with an uncertainty of about 0.2. Translated into time using the standard cosmological model, that is approximately 380,000 years after the beginning. The age of the universe in that same analysis comes out at 13.797 billion years, with an uncertainty of 23 million. At that moment the universe became transparent, and every photon that happened to be flying free at that instant simply kept going. Most of them are still going. They have not interacted with anything since. There are about 411 of them in every cubic centimetre of space. Everywhere, uniformly, 410.7, if you want the number that comes out of the current temperature measurement. That temperature, measured by the FIRES instrument on the COBE satellite and refined by Dale Fixon in a 2009 analysis, is 2.72548 Kelvin, with an uncertainty in the 5th decimal place. The spectrum is the most perfect blackbody ever measured in nature, not the most perfect measured in a laboratory, the most perfect measured anywhere, by anyone, including in laboratories. Take a moment with the density figure, because it does not land the first time. 411 photons per cubic centimetre. Your body is roughly 70,000 cubic centimetres. That means something like 29 million photons from the surface of last scattering are inside the volume of your body at any given instant, passing through and being replaced continuously, and this has been true every second of your life and every second of the life of every organism that has ever existed on this planet. They cannot be seen. That is the small cruelty in it. They are microwaves, peaking at a wavelength of around 1 to 2 millimeters, which is roughly 3,000 times too long for any pigment in your retina to respond to. You are permanently soaked in the oldest light in existence, and you have never detected a single quantum of it with your own body. Now, the geometry. The conventional way of putting this is that the cosmic microwave background has been travelling for 13.8 billion years. That is true in terms of coordinate time, but the matter that emitted it is not 13.8 billion light-years away. It is now roughly 45.7 billion light-years away, and the edge of the observable universe sits at about 46.5 billion light-years in every direction, which makes the diameter of everything we can in principle see about 93 billion light-years. That is not a contradiction, and it is not a violation of anything. Space expanded while the light was in transit. The light covered 13.8 billion years worth of travel, and the ground underneath it stretched, and there is a detail in that expansion which almost nobody mentions in public, and which I think is the single most disorienting fact in observational cosmology. The surface of last scattering, the shell of matter whose radiation we are receiving right now, is receding from us at approximately twice the speed of light, not close to the speed of light, twice it. And it was receding faster than light when it emitted the radiation we are currently detecting, which means those photons, in the first stretch of their existence, were actually moving away from us. They were losing ground. The space between us and them was growing faster than they could cross it. Only later, as the expansion rate in their vicinity dropped, did they begin to close the distance. The light that is warming your skin by roughly nothing right now spent its early existence receding. Nothing here breaks relativity. No local object outruns a local light beam. The prohibition in relativity is on things moving through space faster than light, and expansion is not motion through space. Every galaxy involved is sitting still in its own neighbourhood. It is the neighbourhoods that are separating. But hold that image, because it does something to the standard picture of the photon as a little bullet crossing a gap. This is not a bullet crossing a gap. This is a null path threaded through a geometry that was actively deforming underneath it, arriving at a destination that did not exist when it was emitted, from a source that has since been carried 3 times further away than the distance the light appears to have covered. And the entire structure of that journey, all 13.8 billion years and 45 billion light years of it, is recorded by the photon as 0. The microwave background is the oldest light, but it is not the oldest starlight, and the hunt for that has become one of the more competitive activities in observational astronomy. For years, the record holder was a galaxy called GN11, found in Hubble data by Pascal Oesch and colleagues in 2016 at a redshift of 11.09. That was already extraordinary. Then the James Webb Space Telescope came online and the records started falling annually. In 2024, the JADE survey team confirmed a galaxy designated JADE's GSZ 14-0 using the NIRSPEC instrument to get a spectroscopic redshift of 14.18, which places it about 290 million years after the beginning. The press releases quoted a slightly different number, 14.32, taken from the imaging rather than the spectrum, and both figures are floating around in the literature, which is a good example of why you should always ask which measurement a number came from. Then on the 16th of May 2025, a team led by Rohan Naidu at MIT imaged something brighter and further. The paper, published in the Open Journal of Astrophysics under the title A Cosmic Miracle, reports a spectroscopic redshift of 14.44 for an object now called MOM-Z14. That light left its source roughly 280 million years after the Big Bang. The light travel distance is about 13.5 billion light years. The present proper distance of the object, accounting for expansion, is around 33.8 billion. By the time you watch this, that record may already have fallen. It usually does. What I want you to notice is that every one of those photons is in the same condition as the ones from the naked eye burst and the ones from recombination. 13.5 billion years of coordinate time. 0 proper time. A young galaxy in the first 2% of cosmic history and a superconducting detector on an instrument sitting at a Lagrange point 1.5 million kilometers from Earth, separated by nothing. But there is a complication in all of these numbers, and I want to put it in front of you honestly, because I would rather lose the clean version of the story than launder a figure I know is contested. We do not actually agree on how old the universe is. The 13.797 billion year figure comes from the Planck satellite's analysis of the cosmic microwave background, and within that framework it is extremely precise, with an uncertainty of about 23 million years, which is around 1/6%. It depends on a parameter called the Hubble constant, which sets the current expansion rate of the universe and therefore how far back you have to run the clock. Planck's value for the Hubble constant, inferred from the microwave background, is 67.4 kilometers per second per megaparsec, with an uncertainty of half a unit. The other way to measure it is to go out and look. Find objects whose intrinsic brightness you know, measure how bright they appear, get a distance, measure how fast they are receding, and divide. Cepheid variable stars calibrate the distances. Type 1a supernovae extend the ladder further out. The team that does this most carefully, led by Adam Rees, and known by the acronym SH0ES, published a value in 2022 of 73.04 with an uncertainty of about 1, 67.4 with an uncertainty of half, 73.04 with an uncertainty of 1. Those are not compatible. The discrepancy is around 5 standard deviations, which in particle physics is the threshold at which you are permitted to announce a discovery. 2 well-understood methods, applied by careful people using the best instruments ever built, disagree about the expansion rate of the universe by an amount far larger than either team's stated error bars. This has a name. It is called the Hubble tension, and it has been getting worse rather than better for about a decade. The James Webb Space Telescope was widely expected to resolve it, because its infrared resolution is sharp enough to eliminate the main suspected systematic, which is the possibility that Cepheid variables in distant galaxies are contaminated by unresolved neighbouring stars. Webb looked. The result was that both camps came back more confident. Wendy Friedman's group at Chicago, running a program that uses several independent distance indicators, published in 2024 a combined value in the neighbourhood of 70, with an uncertainty of about 1.5, and argued that the tension eases substantially and may not be real. Rees's group published their own Webb analysis and got 72.6 with an uncertainty of 2, and argued that the crowding hypothesis is now definitively ruled out and that the high value stands. At the American Astronomical Society meeting in January of 2025, Dan Skolnick at Duke described the situation using the word crisis. I want to be careful about how I frame this, because there is a version of it that turns into conspiracy, and it does not deserve that. Nobody is hiding the Hubble tension. It is discussed constantly in the literature and at every relevant conference. There are hundreds of papers proposing resolutions, most of them involving new physics in the early universe, none of them accepted. But notice how the number reaches you. Every documentary, every article, every textbook diagram gives the age of the universe as 13.8 billion years, stated as a fact, with no qualification. That figure is model-dependent. It rests on a parameter that 2 independent measurement techniques disagree about at 5 sigma, and the disagreement is currently the biggest unresolved problem in observational cosmology. You were given a number to 2 significant figures and not told that the field cannot currently agree on the input. And here is the part that ties back, and it is the reason I brought this up rather than leaving it out. The Hubble tension changes the age of the universe. It changes the moving distance to the last scattering surface. It changes how far away MOM Z14 is, and how long its light has been in transit by our reckoning. Every number I have given you in coordinate time carries an unstated asterisk attached to a 5 sigma disagreement. It does not change the 0. Whatever the Hubble constant turns out to be. Whether the universe is 13.8 billion years old, or 12.8, or 14.5, the interval along a null path is exactly 0. It does not depend on the expansion rate. It does not depend on the cosmological model. It does not depend on any parameter anyone is currently arguing about. It falls directly out of the metric. And it would be the same in a universe with completely different contents. Every quantity we quote about the history of the universe is provisional. The one quantity nobody has to revise is the one that says no time passed, which raises a question that sounds technical and turns out not to be technical at all. If the light stretched, it lost energy. Where did the energy go? I want to be very careful here, because this is the point in the story where I stopped being able to hold the standard picture together, and it took me an embarrassingly long time to work out that the reason I could not hold it together is that it is not true. A photon's energy is set by its frequency. Higher frequency, more energy. When the universe expands, the wavelength of light in transit stretches with it, the frequency drops, and the energy of each photon falls in direct proportion. The cosmic microwave background was emitted at a temperature of about 3000 Kelvin. It arrives at 2.725. That is a factor of roughly 1100. Every single photon in the CMB has lost about 999 thousandths of the energy it had when it was emitted. The total radiation energy in the universe today is a tiny fraction of what it was at recombination, and the number of photons has not changed. Nothing absorbed them, nothing scattered them. There is no reservoir anywhere holding the difference. The energy is gone. It did not go somewhere. It is not stored in the gravitational field. It is not converted into the expansion. It is not sitting in some cosmic account waiting to be balanced. Energy is not conserved in general relativity. Not locally violated in some exotic edge case. Not conserved in a way that requires careful bookkeeping. Globally, in an expanding universe, there is no conserved total energy, and there is no way to define one. The reason is a theorem, and it is one of the most beautiful results in mathematical physics, and it was proved by Emmy Noether in 1918. Every continuous symmetry of a physical system corresponds to a conserved quantity. Symmetry under spatial translation gives you conservation of momentum. Symmetry under rotation gives you conservation of angular momentum. And symmetry under translation in time, the fact that the laws of physics are the same today as they were yesterday, is what gives you conservation of energy. An expanding universe is not the same today as it was yesterday. The metric itself is changing. Time translation is not a symmetry of the spacetime, and so, by Noether, there is no globally conserved energy. The conservation law does not fail. It was never there to begin with. Sean Carroll wrote about this directly in 2010, and the phrasing is worth having exactly. If we keep track of a certain fixed number of photons, he wrote, the number stays constant while the energy per photon decreases, so the total energy decreases. And then the part that matters. In general relativity, spacetime can give energy to matter, or absorb it from matter, so that the total energy simply is not conserved. That is a working cosmologist saying, in plain language, that the single most famous conservation law in physics does not apply to the universe as a whole. This is not a fringe position. It is standard general relativity. It is in Peebles. It is in Harrison's Cosmology textbook. Any relativist you ask will confirm it without hesitation, and probably look slightly puzzled that you consider it noteworthy. And it appears nowhere in public science communication. It does not turn up in documentaries. It is not in the school curriculum. It is not in the popular books. Millions of people are taught, correctly for all practical laboratory purposes, and incorrectly as a statement about the universe, that energy can neither be created nor destroyed, and the actual professional consensus is that at cosmological scale this is simply false, and the discrepancy is not considered interesting enough to mention. There is a caveat, and I will give it, because I am not going to overclaim. What survives is a local statement. In any small enough region, energy and momentum are conserved in the precise covariant sense, and that local law is exact and unbroken. Some writers prefer to say the energy goes into the gravitational field, which sounds reassuring, but general relativity has no local definition of gravitational energy density. There is no place to put it. When you try to write down a total energy for the universe using the standard machinery, what you get is a term that lives on the boundary at infinity, and in a universe without a suitable boundary, you do not get a number at all. Take the whole picture in one piece. A photon leaves the surface of last scattering. It crosses 13.8 billion years of coordinate time. It loses 99.9% of its energy to an expansion that has no destination for it. It arrives in a detector on a planet that did not exist. And for the photon, none of it occurred. There was no transit and no loss and no duration whatsoever. From its own path, emission and absorption are one undivided event, and everything that appears to have happened in between, including the erasure of almost all of its energy, is something that happened to the geometry rather than to it. And then there is the part that I find close to comic, if you have the right sense of humour about institutional physics. In 2013, a physicist named Julian Heek published a paper in Physical Review Letters titled "How Stable is the Photon?" The question is serious. If the photon has even a minuscule rest mass, and the experimental upper bound allows something around 10 to the minus 18 electron volts, then it is permitted to decay into lighter particles. If photons decayed, the cosmic microwave background spectrum would be distorted, because photons of different energies would decay at different rates, and the blackbody curve would be deformed. The blackbody curve is not deformed. It is the most perfect one ever measured. Therefore, the photon must be extraordinarily stable, and Heck was able to put a hard lower bound on its lifetime. The bound works out to around 10 to the 18 years in our frame, about 100 million times the current age of the universe. But look at how the calculation is set up. To get a lifetime, you need a proper time, and to get a proper time, you need a rest frame. Heek states the bound explicitly in the rest frame of the photon. 3 years in the photon's own frame, then multiplied by a time dilation factor of order 10 to the 15 to get the laboratory number. Physical Review Letters published a lower bound on the photon's lifetime, in the photon's rest frame, in a discipline that teaches undergraduates that the photon's rest frame does not exist. Nobody is being dishonest. Everyone involved knows precisely what they mean, and the calculation is a formal device that gives the right answer. But it tells you something about the status of that objection. When physicists actually need to compute with the photon's own frame, they use it. They use it in a top-tier journal, in print, without embarrassment. The frame that cannot be discussed with a student is available whenever a result depends on it. Which brings me to what I think is the real question, the one underneath everything so far. What is the thing that arrives? The mental image nearly everybody carries, including a lot of people who work with light professionally, is of a small object. A packet, a tiny discrete parcel of energy that departs a source, travels along a trajectory, and lands on a target. It is the image the word particle is doing to you, and it is doing it whether you consent or not. That image is wrong in a specific and well-documented way, and the correction was published in 1949 and has been sitting there ever since. Theodore Newton and Eugene Wigner set out to answer what sounds like a housekeeping question. In relativistic quantum mechanics, what does it mean for a particle to be at a location? They wanted a proper mathematical definition of a localized state, one that respects relativity, and they wanted a position operator to go with it, in the same way that momentum and energy have operators. This is not exotic. It is the sort of thing you do when you are building the foundations of a theory. For massive particles it worked. For massless particles of spin 1 or higher, it did not. There is no position operator for the photon. There are no localized photon states, in the sense Newton and Wigner defined. And what I want you to hear is the sentence they wrote about it, in the paper, in 1949, because it is one of the more honest admissions in the literature. We found that no localized states in the above sense exist. This is an unsatisfactory, if not unexpected, feature of our work. Unsatisfactory. Not surprising, they say, but unsatisfactory. The obstruction is structural. Maurice Price had already noticed part of it the year before. The electromagnetic field is transverse. The divergence of the electric field in free space is zero, which is a constraint that couples what the field is doing at every point to what it is doing everywhere else. Multiplying the field by a position vector, which is what you do to build a position operator, breaks that condition. The transversality is not a technicality. It is what makes light light. And there is a deeper obstruction underneath it. Gerhard Hegerfeld proved that if you insist on a strictly localized state with a well-behaved position operator in a relativistic theory, the state immediately develops tails that spread outside the light cone. You get superluminal propagation. Relativistic causality itself is what forbids the photon from having a definite location. Quantum field theory does the sensible thing and stops treating position as an observable for light. Position becomes a parameter, a label on the field, not something a photon has. You can say where a photon interacted. That is a real, recordable event, and the interaction destroys the photon. You cannot say where it was on the way, not because the measurement is difficult, because there is no such quantity. Now stack that with the field theory picture of what a photon is in the first place. It is not a small object with an identity, it is an excitation of the electromagnetic field, a quantum of energy in a mode. Photons are indistinguishable bosons, which in quantum mechanics is not a statement about them being similar. It is a statement that there is no fact of the matter about which one is which. There is no serial number. There is no continuous trajectory carrying a label from one end to the other. Which means the phrase I have been using this entire time, the same photon that left the star arrived in the eye, does not have a rigorous meaning. There was an emission event. There was an absorption event. There is a null path connecting them across which a quantum of the electromagnetic field was transferred. There was never a little thing in flight, at a location, with a history that we could in principle have followed. The transfer is real. The transferred object, in the sense you are imagining it, is not there. And now put that next to the zero. The thing that connects the death of a star to a human retina across 7.5 billion years has no duration, no location during transit, and no identity. 3 of the 4 properties we would ordinarily use to say that something exists as a persisting entity are absent. What remains is the connection itself, the relation between 2 events, and the relation is all there is. I want to slow down, because there is a version of this that sounds like word games, and I want to show you that it is not. Go back to the eye. In 1942, 3 researchers named Selig Hecht, Simon Schleer and Maurice Perrin published a paper in the Journal of General Physiology called Energy, Quanta and Vision. It has been cited well over 1,000 times, and it is one of the foundational documents of visual science. What they established, using nothing but a dark room, a carefully calibrated dim light source, and human subjects, is that the rod cells in the human retina respond to individual photons, not to clusters, not to a threshold flux, to one, and that a conscious visual sensation, the experience of seeing a flash, requires the absorption of somewhere between 5 and 14 photons distributed across a patch of about 500 rods. 5 to 14. That is the entire margin between darkness and perception in the human visual system. Your eye is, at the low end of its range, a quantum detector operating close to the physical limit of what any detector could do. For 74 years, that result stood as a statement about small numbers of photons. Then, in 2016, a group led by Alipasha Vaziri at the Research Institute of Molecular Pathology in Vienna, with Jonathan Tinsley as first author, published in Nature Communications the experiment that closed the gap. They used a source called spontaneous parametric down conversion, which takes a pump photon and splits it inside a crystal into two lower energy photons that are correlated. Detect one, and you know with near certainty that its partner was emitted. That gives you something no ordinary light source can give you, which is the ability to deliver exactly one photon at a known instant, and to know, independently of your subject's report, whether the photon was actually there. 3 subjects. 30,767 trials. The detection rate for a single photon came out at 51.6%, against a chance baseline of 50. That gap is small, and it is statistically robust, and it means that a human being, under the right conditions, can register the arrival of one quantum of the electromagnetic field. They also found something nobody had predicted. If a photon had arrived in a preceding trial, the probability of detecting the next one went up on a timescale of seconds. The retina primes. A single quantum leaves the system in an altered state that persists. Now put the two facts together, and be careful, because I want to state this at exactly the strength the evidence supports, and not 1 degree stronger. On the 19th of March 2008, photons emitted 7.5 billion years ago arrived at the surface of the Earth in sufficient numbers to be visible to the unaided eye. Human rod cells respond to individual photons. There is no additional physics required to connect those two statements. Somewhere, that morning, in a rod cell, in a human retina, an individual quantum of the electromagnetic field that had been in transit since before the solar system existed was absorbed by a single molecule of rhodopsin, and that molecule changed shape, and a signal went down an optic nerve, and something in a brain registered a faint point of light in the constellation Boötes. That is a real event. It happened. It required no unusual interpretation of quantum mechanics, and no speculation, and the absorbing molecule and the dying star were, along the path that connected them, separated by nothing at all. No time, and no transit either. The rhodopsin molecule and the collapsing stellar core were, in the only accounting the light itself provides, in direct contact. That is what I could not stop thinking about, and it is the reason this script exists. There is a physical relationship, exact and calculable and entirely uncontroversial, in which a molecule inside a human head touches the interior of a star that died before the Earth was assembled. Not metaphorically. The interval between them is 0. Zero interval, in Minkowski geometry, is the smallest separation the universe permits between two distinct events. It is as close as two things can be without being the same thing. And if you are inclined to say that this is just a quirk of the mathematics, and cannot mean anything physical, I would ask you to hold that thought for about 40 minutes. Because there is a theorem coming that says the causal structure defined by those zero intervals is not a quirk of the mathematics. It is very close to being the whole of the mathematics. But first, there is a set of experiments that took ancient light and did something to it that I still do not entirely know how to think about. John Archibald Wheeler was one of the strangest and most productive minds in 20th century physics. He coined the term black hole. He coined wormhole. He worked on the Manhattan Project, and on the hydrogen bomb, he supervised Richard Feynman's doctorate, and he spent the last decades of his life asking questions that most of his colleagues considered borderline unprofessional. In 1940, Wheeler telephoned Feynman with an idea. All electrons in the universe, he suggested, are the same electron, a single particle weaving forwards and backwards through time, appearing as an electron on the forward passes and as a positron on the backward ones, and threading through the present moment so many times that it appears to us as an enormous population of identical particles. That would explain, he pointed out, why every electron has precisely the same mass and charge. They are all one object seen at different points along its world line. Feynman thought it was absurd and also could not immediately refute it, and it went on to seed his own work on positrons as electrons moving backwards in time, for which he shared a Nobel Prize. I bring Wheeler in here because in 1978 he proposed something that took the same essential move, the willingness to let a quantum system's past remain unfixed, and turned it into an experiment that could actually be performed. The delayed choice experiment. The setup is the double slit, or an interferometer version of it. A single photon goes through an apparatus that can be configured in one of two ways. In one configuration, you see interference, and the standard language is that the photon went both ways. In the other, you see which path it took, and the standard language is that it went one way. Wheeler's question was what happens if you wait to decide which configuration to use until after the photon has already passed the point where it would have had to commit. Can one choose, he wrote, whether the photon shall have come through both of the slits, or only one of them after it has already traversed the screen? The word shall have, future perfect tense, applied to the past. He knew exactly what he was writing, and then he took it further, because Wheeler was constitutionally incapable of stopping at the laboratory scale. In the early 1980s, he described the cosmic version. Take a quasar whose light reaches Earth along two different paths because an intervening galaxy bends it gravitationally. That light left its source billions of years ago and took two routes around a galaxy. Set up your apparatus tonight. Decide tonight, on a whim, whether to combine the two beams and look for interference, or to look at each path separately. According to the standard formalism, your decision tonight determines whether that light travelled one route, or both, across a journey that began before there was anything on Earth capable of deciding anything. The laboratory version was carried out properly in 2007. Vincent Jacques and colleagues published in Science, using single photons in a Mach-Zehnder interferometer with the beam splitter inserted or removed by a quantum random number generator, whose output was generated at a location relativistically separated from the photon's entry point, so that no signal at or below light speed could have carried the decision back. The result matched quantum mechanics exactly. The authors described it as an almost ideal realization of Wheeler's proposal. In 2015, a group at the Australian National University, led by Andrew Truscott, with Roman Manning as first author, published in Nature Physics the same experiment performed with a single metastable helium atom instead of a photon. A massive particle. Same result. But the experiments that actually make my hands cold are the ones that came next, because they did not use a random number generator in a lab. They used the sky. Bell's theorem, published by John Stuart Bell in 1964, established that if the world is local, and if measurement outcomes are determined by properties the particles carry with them, then certain statistical correlations must obey an inequality. Quantum mechanics predicts violations of that inequality. Experiments have observed violations of that inequality since the 1970s, with increasing rigour, closing loophole after loophole. Bell himself deserves a sentence here, because his story fits the pattern I have been tracking, and because he did the work in his spare time. He was employed at CERN as a particle physicist and accelerator designer. The foundations of quantum mechanics were not his job. They were something he thought about on unpaid leave, and in the evenings, in a field that was at the time considered slightly disreputable, the sort of thing a serious physicist did not put on a grant application. He published the theorem in a short-lived journal called Physics, which folded a few years later, partly because he wanted to keep the page charges off his employer. The paper is now one of the most cited in the history of physics. Henry Stapp called it the most profound discovery of science. It took roughly a decade before anybody took it seriously enough to test, and the young physicists who did test it were warned that the work would damage their careers. John Bell died of a cerebral hemorrhage in Geneva on the 1st of October, 1990. He was 62. He had, by several accounts, been nominated for the Nobel Prize that same year. The prize is not awarded posthumously. The experimental confirmation of his theorem won the Nobel in 2022, 32 years after his death, shared by Alain Aspect, John Clauser and Anton Zeilinger, and the citation described work that would not have existed without him. That is another one for the count. But one loophole is philosophically nasty and cannot be closed in the ordinary way. It is called the freedom of choice loophole, sometimes the setting independence loophole. The Bell argument assumes that the choice of which measurement to make is independent of the hidden properties of the particles. If instead there is some common cause in the past that correlates your choice of measurement setting with the state of the particles, the whole argument collapses. No amount of shielding fixes this, because the correlation could have been established at any point in the past, arbitrarily far back. So, a group of physicists asked a genuinely strange question. How far back can we push it? In 2017, Johannes Handsteiner and colleagues, with Anton Zeilinger among the authors, published in Physical Review Letters an experiment called Cosmic Bell Test, in which the measurement settings for a Bell test were determined in real time by the colour of photons arriving from individual stars in the Milky Way. Light that had left those stars roughly 600 years ago. The detector angles were set by starlight emitted before Galileo was born. They measured a Bell parameter of 2.65, comfortably above the classical limit of 2. If some conspiracy in the past was setting up the correlation, it had to have been in place at least 600 years ago. Then in 2018, Dominic Rausch, with a team including Zeilinger, Alan Guth, David Kaiser, Andrew Friedman and Jason Galicchio, published the version that pushed it as far as it can currently be pushed. Instead of stars, they used quasars, high redshift quasars, whose light was emitted billions of years ago. That light, arriving at telescopes in the Canary Islands, chose the measurement settings. They observed a violation of Bell's inequality at 9.3 standard deviations. The probability of that occurring by chance is around 7 times 10 to the minus 21. And the conclusion they were able to draw is the part that matters. Any local realist mechanism that explains the results by correlating measurement settings with particle properties must have operated at least 7.8 billion years ago. The experiment excludes such a mechanism from 96% of the spacetime volume of Earth's past light cone. From the Big Bang to the present, 96% of it is ruled out. Read that again slowly. A group of physicists used light emitted billions of years ago, before the Earth existed, as the random input to a laboratory experiment in order to constrain the behaviour of the universe across almost the entirety of its history. They could do that because the light carries no time. That is not a poetic gloss on the experiment. It is the operational basis of the experiment. The quasar photon arrives having undergone nothing, having recorded nothing, having no internal state that could have been influenced by anything in between. It is a message with no messenger and no journey, and that is precisely what made it usable as an unimpeachable source of randomness. The physicists trusted it because nothing could have happened to it. They designed an experiment around the zero. There is an interpretation of all this that is genuinely fringe, in the sense that a minority of physicists hold it, and I am going to give it to you clearly labelled as such, because I think you can handle a marked speculation, and because it takes the zero more seriously than any other framework does. It begins with something ordinary, which is that Maxwell's equations have 2 families of solutions. Write down the wave equation for the electromagnetic field and solve it. You get retarded solutions, waves that leave a source and propagate forwards in time. You also get advanced solutions, waves that converge on a source from the future and propagate backwards in time. The mathematics produces both. They are equally valid. They are not an artifact of sloppy derivation. Standard practice is to discard the advanced solutions on the grounds that they are unphysical, and that has been standard practice since the 19th century. Nobody hides this. It is stated in every textbook. But notice what is happening. The equation is time-symmetric. The universe, as we experience it, is not. So a choice is made, by hand, at the point where the theory meets reality, and the discarded half is discarded because it offends our sense of how causation should work. In 1945 and 1949, Wheeler and Feynman published a pair of papers that refused to make that choice. Their absorber theory used both solutions in equal measure. The consequence is that a charged particle does not radiate on its own. It radiates because of a response from the absorbers in its future. The emission and the eventual absorption are not two separate events with a delay between them. They are a single joint process spanning the interval. In 1986, John Cramer at the University of Washington extended this to quantum mechanics in a paper in Reviews of Modern Physics called The Transactional Interpretation of Quantum Mechanics. The picture goes like this. An emitter produces what Cramer calls an offer wave, the ordinary quantum wave function propagating forwards in time. A potential absorber, on receiving it, produces a confirmation wave, the complex conjugate, propagating backwards in time to the moment of emission. The two waves interfere along the connecting path, and where they reinforce, a transaction completes. Energy, momentum and angular momentum are transferred, and every conservation law is satisfied, and the event is done. In this picture, a quantum event is not a thing that travels. It is a handshake, negotiated across the interval, in which both endpoints participate simultaneously. I want to be exact about the status of this. Cramer's interpretation makes no predictions that differ from standard quantum mechanics. It is not testable against the orthodox view. Most physicists do not hold it. It has known technical difficulties, and the backwards propagating confirmation wave is exactly the sort of thing that makes people uneasy for reasons that are not purely rational. Do not go away thinking this is established. But hold it against the zero. Because in every other interpretation, the transactional handshake sounds like a violation of temporal order. Something reaches backwards. Something arrives before it left. And that offends. Along a null path, there is no backwards. There is no forwards. There is no order to violate. The interval between emission and absorption is zero, which means there is no fact of the matter about which came first in any frame-independent sense along that connection. What we call the delay between the two events is a feature of how massive observers, embedded in a specific slicing of spacetime, describe a relation that itself contains no duration. The transactional interpretation looks bizarre only if you assume light travels. If light does not travel, if the connection is a single geometric relation with no interior, then the handshake is not a strange addition to the physics. It is a description of what a null relation actually is. I do not know whether that is true. I want to say that plainly. There are days I find it the most natural reading of the entire structure, and days I think it is a category error dressed in equations. But it is the only interpretation I have found that treats the zero as information rather than as an embarrassment to be managed. And here is the thing that should sit uncomfortably with you regardless of which interpretation you prefer. Every one of them agrees on the zero. Copenhagen agrees, Many Worlds agrees, Pilot Wave agrees, the transactional interpretation agrees. Every framework in quantum mechanics, and general relativity underneath all of them, agrees that the proper time along a null path is zero, and that emission and absorption are separated by no interval. They disagree violently about what happens at the moment of absorption, whether a wave function collapses, whether the universe branches, whether the particle had a definite path. They disagree about nearly everything. The zero is the one thing nobody argues about, which means it is not an artifact of interpretation. It is the substrate that every interpretation is built on top of, and it is the part of physics that has been sitting in the open for over a century, in the textbooks, in the graduate courses, unhidden and unmentioned, waiting for somebody to ask what it implies. Somebody did ask, in 1977, and the answer he found is, I think, the most underreported result in modern physics. David Malament was a philosopher of physics, and in 1977 he published a paper in the Journal of Mathematical Physics with a title so dry that you could read it a dozen times without noticing what it says. The class of continuous time-like curves determines the topology of spacetime. He was building on work by Ephraim Kronheimer and Roger Penrose from 1967, and on results by Stephen Hawking, Alan King and Peter McCarthy. And what he proved is this. Take a spacetime, throw away the metric, throw away the distances, the durations, the geometry, everything you would use to measure anything. Keep only one piece of information, which is the causal structure. For every pair of events, keep the answer to a single yes or no question. Could a light signal or a slower signal get from this one to that one? That is all. A vast list of yes and no. No numbers. Malament proved that from that alone. Provided the spacetime satisfies a mild condition about distinguishing points, you can reconstruct the topology of the spacetime, its differentiable structure, and its metric up to a single overall scaling factor at each point. The metric in 4 dimensions has 10 independent components. The causal structure fixes 9 of them. The one thing it does not give you is scale. It does not tell you how big anything is. Everything else, the entire geometry of the universe, the curvature, the shape, the way spacetime bends around mass, all of it is already encoded in the bare question of which events can send signals to which other events. Sit with the size of that. The causal structure is defined by light. The light cone at every point is exactly the boundary between what can be reached and what cannot, and that boundary is drawn by the paths that light takes, which are precisely the paths along which the interval is 0. The null structure is the causal structure. They are the same object. The statement Malament proved, translated out of the technical language, is that the set of all zero interval relations in the universe determines the geometry of the universe, up to one number per point. Light does not travel through spacetime. The relations that light defines are what spacetime almost entirely is. I have read a lot of physics popularization. I have never once seen this stated in it. It is not obscure. It is a standard result cited routinely in the mathematical relativity literature, and it is the foundation of an entire research program in quantum gravity. In 1987, Luca Bombelli, Johann Lee, David Meyer, and Raphael Sorkin published a paper in Physical Review Letters proposing that spacetime is fundamentally discrete, a set of events with nothing but causal ordering between them, and that the geometry emerges from that ordering plus a count of how many elements there are. Their slogan for it is 4 words long. Order plus number equals geometry. Order gives you 9 components of the metric. Number gives you the 10th. That is the entire structure of spacetime, assembled from a list of which events can talk to which other events, and a tally. Sorkin put the point directly. The causal order, he wrote, unifies within itself the other structures, topology, differentiable structure and metric, up to a local rescaling. And now I want to fold this back onto what we have already established, because the combination is where it stops being an abstract theorem. The causal relations that build the geometry are relations of zero interval, every one of them. The light cone is nothing but the collection of directions in which the interval vanishes, which means the architecture of the universe is made out of the connections that record no duration. The stuff that has duration, the stuff with mass, the stuff that ticks, that ages, that has a proper time, is not the framework. It is the content sitting inside the framework. The framework is built from null relations, and null relations have no time in them at all. Every one of us has an intuition that time is the medium and things happen inside it. The theorem says the opposite. The timeless relations are the medium. Duration is what happens to the small, heavy contents. And I said earlier that this would come back, that the question of what has proper time and what does not would arrive with the entire history of the universe attached to it. Here is that history. The ratio of photons to baryons in the universe has been measured to real precision. The Planck data give a baryon to photon ratio of about 6.1 times 10 to the minus 10, which the 2020 analysis by Brian Fields and colleagues in their review of Big Bang nucleosynthesis after Planck states as 6.104 with an uncertainty of about 0.06 in the conventional units. Invert it. There are roughly 1.6 billion photons in the universe for every single baryon. For every proton or neutron, for every particle that has mass, that has a rest frame, that has a proper time, that can be part of a clock or an atom or a molecule or a cell or a brain, there are 1.6 billion quanta of light that have none of those things. Don Page put the totals in a paper in 2016. Around 10 to the 80 baryons in the observable universe. Around 10 to the 89 photons. By count, the universe is not made of matter with a trace of light in it. The universe is made of light with a contamination of matter at the level of 1 part in 1.6 billion. And for that 1.6 billionth of it, and only for that fraction, does anything ever happen. I want to stop the descent for a moment, because there is a set of smaller corrections that belong here, and because I think the pattern they form matters more than any one of them individually. You have almost certainly been told that when light passes through glass or water it slows down, and that the reason it slows down is that the atoms in the material absorb the photons and then re-emit them, and all that absorbing and re-emitting takes time. That explanation is wrong, and it is wrong in a way that falls apart the moment you look at it. Atomic absorption is not a general-purpose process. Atoms absorb at specific discrete energies corresponding to specific transitions. Ordinary glass transmits the entire visible spectrum continuously, and its refractive index varies smoothly with frequency, which is not what a set of discrete atomic transitions would produce. And there is a worse problem. When an excited atom ray emits, it emits in a random direction. If the absorption and ray emission story were correct, light entering a lens would exit as a diffuse glow scattered in all directions. Lenses would not work. Your glasses would not work. Windows would be frosted panels. What actually happens is that the oscillating electric field of the light drives the bound electrons in the material into forced oscillation. Because the driving frequency is not at resonance, the electrons oscillate out of phase with the driver, lagging by close to 90 degrees. Those oscillating charges radiate their own field. The original wave and the re-radiated field superpose, and the sum of them has its crests displaced slightly backwards relative to where the original wave's crests would have been. Do that continuously through a medium and the net wave advances more slowly. It is a collective interference effect involving the whole material at once, not a relay race between individual atoms. Between the atoms, the disturbance still propagates at c. It always propagates at c. The speed of light in a medium is a property of the superposition, not of the quanta. That is the first one. Here is the second. The Big Bang did not happen at a point. There is no location you could travel to and find the site of it. The expansion is not an explosion in space, it is an expansion of space. And it happened everywhere at once, in every region including the one your body currently occupies. The cosmic microwave background arrives from every direction, not because we are looking outward at a distant fireball, but because we are inside the remnant. The material that emitted the microwaves currently falling on your skin is the same kind of material that eventually condensed into you. Somewhere out there, 13.8 billion years ago, something in this region emitted photons that are now arriving at telescopes 5 billion light years away, being interpreted by whatever is there as the edge of everything. Third, the recession velocities of distant galaxies exceed the speed of light, routinely, and there is nothing controversial about it. Objects beyond a certain distance recede faster than c, because the intervening space is expanding, and we observe many objects whose recession velocity exceeded c at the moment they emitted the light we are now receiving. The prohibition in relativity is local. Nothing overtakes a light beam in its own neighbourhood. The universe is under no obligation to keep its overall geometry beneath a speed limit that applies to motion through it. Fourth, and this one is a correction to a thing I have heard said in a documentary, photons do not age. They do not decay under any established physics. They have no internal clock, and the experimental bounds on their stability are the ones I gave you earlier. There is no process by which a photon gets old. Fifth, and this one is the opposite case, because it is a claim that is basically true, and that gets quoted with a precision it does not have. You have probably heard that when you tuned an old analog television to a dead channel, some fraction of the snow on the screen was the cosmic microwave background. The usual figure given is 1%. It traces back to a Scientific American article from February 2004 by Wayne Hugh and Martin White called The Cosmic Symphony, in which they wrote that tuning a set between channels shows you static of which about 1% comes from the microwave background. Bill Bryson repeated it. Everyone repeated it. The underlying physics is sound. Those old sets had front-end sensitive in the ultra-high frequency range. The microwave background does deposit power in that range, and a detector at room temperature looking at a 2.7 Kelvin sky gives you roughly the ratio you would expect. But the actual fraction depends on the receiver, on the antenna, on where you are standing, on how much terrestrial interference and galactic radio emission and thermal noise from the set's own electronics was in the mix. Most of the snow was the amplifier. Some of it was the atmosphere, the sun, and the galaxy. 1% is a plausible order of magnitude that has been passed between writers for 20 years without anybody measuring it. I am including it because I like the image, and because I think you should know which of the things you have been told are measurements, and which are estimates that hardened into facts through repetition. The measurement that is real and that deserves more attention than the television anecdote is what COBE did. The Cosmic Background Explorer launched in November of 1989. Its FIRUS instrument compared the sky against an onboard reference blackbody cooled with liquid helium, and within 9 minutes of data it had a spectrum. When John Mather presented it at the American Astronomical Society meeting in January 1990, the plot of the measured points against the theoretical blackbody curve was so exact that the error bars were smaller than the thickness of the line, and the room gave it a standing ovation. Physicists do not generally applaud graphs. That curve is the most perfect blackbody spectrum ever measured, anywhere by anyone, including in laboratories where the source was built on purpose to be perfect. The universe outperforms our best instruments at being a thermal emitter. The second instrument, the differential microwave radiometer, mapped the tiny variations in that temperature across the sky, at the level of 1 part in 100,000, and those variations are the seeds from which every galaxy formed. George Smoot announced them in 1992. Mather and Smoot shared the Nobel Prize in 2006, and Ralph Alpha, who had calculated the temperature of that radiation 4 years before it was mapped, was still alive to watch that prize announced. And it was not his. Now, the pattern. Every one of these corrections is standard textbook material. Not one of them is contested. Any working physicist will confirm all 4 without hesitation, and every one of them is routinely taught wrong, or not taught in the material that reaches the public. I do not think this is a conspiracy, and I want to be clear that I have never thought that. There is no committee suppressing the fact that energy is not globally conserved. What there is instead is a set of incentives that all point the same direction. Simplified explanations are easier to give and easier to grade. Textbook authors inherit the previous edition. Science communicators optimize for the feeling of understanding rather than for understanding, because the feeling is what gets shared. And every one of these corrections, if stated honestly, opens a door to a question that takes an hour to answer properly and does not have a satisfying end. The mechanism is not suppression. The mechanism is that uncomfortable truths are expensive to communicate, and comfortable falsehoods are cheap. And over 100 years the cheap version wins by default, repeatedly, without anyone deciding anything. Which is how you end up here, an intelligent adult, decades into your life, being told for the first time that the geometry of the universe is built out of relations that contain no time, and that this has been in the literature since before your parents were born. And there is one more thing in that category. It is the largest one. It is the one that Einstein spent the last months of his life writing about, and it has been sitting in special relativity since 1905, and it is not an interpretation. Simultaneity is not absolute. That much has filtered through into general knowledge. What almost nobody has been walked through is how large the effect gets, and what it implies when you scale it up. The rule is straightforward. If 2 observers are moving relative to each other at speed v, then events they consider simultaneous differ in timing by an amount proportional to v times the distance, divided by the speed of light squared. The velocity term is tiny for anything human. The distance term is not bounded. Roger Penrose worked the consequence out in The Emperor's New Mind, published in 1989, and the version he gave has become known as the Andromeda paradox. 2 people pass each other on a pavement. One is walking towards the Andromeda galaxy, 2.5 million light-years away. The other is walking away from it. Ordinary walking pace, a metre or 2 per second. As they pass, they are at the same place at the same moment, and by any ordinary reckoning they share a present. They do not share a present at Andromeda. Their planes of simultaneity, extended out 2.5 million light-years, are tilted relative to each other by enough to separate events there by several days. Penrose's own framing is worth quoting exactly, because he chose the example deliberately. People pass each other on the street, he wrote, and according to one of the 2 people, an Andromedan space fleet has already set off on its journey, while to the other, the decision as to whether or not the journey will actually take place has not yet been made. One pedestrians now contains a launched fleet. The other pedestrians now contains an undecided committee. Neither is wrong. There is no third perspective that adjudicates. Both slices are equally valid descriptions of a single reality, and both are cutting through the same 4-dimensional structure at slightly different angles. Now follow that where it goes, which is what a Dutch physicist named Cornelis Wim Rietdijk did in 1966 in a paper in the journal Philosophy of Science with a title that pulls no punches. A rigorous proof of determinism derived from the special theory of relativity. His argument runs like this. If an event is in the past for some possible observer, then it has happened. It is settled. It is a fact. But given any event you like, anywhere, at any time, there exists some possible observer somewhere in the universe, moving at some ordinary velocity, for whom that event is already in the past at the moment that is now for you. Reitdeck states it flatly. There does not exist an event that is not already in the past for some possible distant observer at the moment that is now for us. The philosopher Hilary Putnam published essentially the same argument independently in the Journal of Philosophy in 1967. And the conclusion, if you accept the premises, is that every event in the history of the universe, including every event you would describe as being in your future, already exists. Not will exist. Exists, the distinction between what has happened and what has not is a feature of your particular slicing, and other slicings are equally valid, and the union of all valid slicings is everything. That is the block universe. Past, present and future all equally real, laid out as a four-dimensional structure that does not change because there is no external time in which it could change. I will give you the honest caveat, because there is one. This is not a proof in the way a mathematical theorem is a proof. Howard Stein published a serious technical objection in 1968, arguing that the argument smuggles in assumptions about what it means for a distant event to be determinate, and it produces no paradox you can observe, because the two pedestrians cannot compare notes about Andromeda without waiting 2.5 million years. The philosophy of time is not settled, and anyone who tells you it is settled is selling something. But notice what does not depend on any of the philosophy. Hermann Weyl, who was one of the finest mathematicians of the 20th century and understood relativity as well as anybody alive, wrote a sentence in 1949 that I have never been able to put down. "The objective world simply is," he wrote. "It does not happen." And notice what the block universe is made of. If the four-dimensional structure is real, then its shape is the metric, and the metric, by Malament, is determined up to a scale by the causal relations, and the causal relations are the null connections. The block, if there is a block, is knitted together by zero-interval relations. The threads holding the whole thing in one piece are precisely the things that record no duration. Light is not something inside the block. Light is the stitching. Michelangelo Besso met Albert Einstein in Zurich in the 1890s. They were both students, they both played the violin, and they became friends in a way that lasted the rest of their lives, which in Einstein's case was not a common outcome. Einstein's relationships tended to burn down. This one did not. Besso is the only person thanked by name in the 1905 paper that introduced special relativity. Einstein called him the best sounding board in Europe. They wrote to each other for nearly 6 decades, and the correspondence is one of the more remarkable documents in the history of science, because in it you can watch Einstein think out loud to somebody he trusted completely. Besso died in Geneva on the 15th of March, 1955. He was 81. About a week later, Einstein wrote to the Besso family. He was 76, he had been ill for years, and he knew he did not have long. The letter is held in the Einstein archives, and the passage everyone quotes reads, in the translation Freeman Dyson used, like this: "Now he has departed from this strange world a little ahead of me. That means nothing." People like us, who believe in physics, know that the distinction between past, present and future is only a stubbornly persistent illusion. I have seen that line used 100 times as a piece of consolation, a sort of physicist's version of a hymn at a funeral. It is not consolation. Read it again with the physics in your hands. He is not saying that Besso lives on in memory. He is saying that Besso's death is a feature of a particular slicing, that the events of Besso's life have not gone anywhere, that they are as real now as they ever were, and that the sensation of loss is an artifact of being a massive object embedded in a foliation of spacetime that moves. He is telling a grieving family that their grief is a coordinate effect. I do not know whether he found that comforting. I do not know whether he expected them to. There is a version of this letter that is one of the coldest documents ever written by a bereaved friend, and there is a version that is a man reaching for the only true thing he knows and offering it because he has nothing else. And I have gone back and forth between those two readings for a long time. Einstein died on the 18th of April, 1955, 28 days after Besso. He had a chance to test his own sentence, and he took less than a month to do it. And there was one more person at the Institute for Advanced Study in Princeton during those years who had taken the block universe further than Einstein ever did in public. Kurt Godel had already done the thing that made him permanently famous, which was to prove in 1931 that any consistent formal system rich enough to describe arithmetic contains true statements it cannot prove. He had emigrated from Austria, and he and Einstein walked home together from the Institute nearly every day. Einstein said in his last years that he came to the office mainly for the privilege of walking home with Godel. For Einstein's 70th birthday, Godel gave him a present. He presented it in a seminar on the 7th of May, 1949. It was an exact solution to the field equations of general relativity, describing a rotating universe. In such a universe, the rotation drags the light cones around with it, tilting them progressively as you move outwards, until at sufficient distance a path exists that returns to its own past. Closed time-like curves. A world line that loops. The solution is valid. It has never been shown to be mathematically flawed. It does not describe our universe, since our universe shows no evidence of the required rotation. But that was never Godel's point. His point was philosophical, and he stated it directly. If a universe governed by these equations can contain closed time-like curves, and if time in such a universe cannot involve any objective lapse, then the objective lapse of time is not a necessary consequence of the equations, and if it is not necessary there, it is hard to argue that it is real here. The intuition that time passes, that events come into being and then cease to be, does not follow from the physics. It is something we bring. Einstein's published response was uneasy. He acknowledged the solution was correct, called it an important contribution, and said the question of whether such solutions should be excluded on physical grounds deserved further investigation. He was, in effect, hoping somebody would rule it out. Nobody has. Godel's later life was very hard. He suffered from a paranoid conviction that he was being poisoned and would eat only food prepared by his wife Adele. In late 1977, Adele was hospitalized for 6 months after a stroke. Godel stopped eating. He died in Princeton on the 14th of January, 1978. The death certificate gave the cause as malnutrition and inanition brought on by personality disturbance. He weighed about 29 kilograms. I am not going to make a joke out of that, and I would ask you not to either. But the shape of it is difficult to ignore. The man who produced the most rigorous argument in the technical literature that the passing of time is not real spent his final months watching a clock he could not stop, and starved. The personal and the physical are not two separate threads in this story. They keep turning out to be the same thread, running in both directions. There is one part of the null path I have not examined, and it is the end of it. Something happens at absorption. It has to. The photon exists, in whatever sense it exists, and then it does not, and its energy is in a molecule, and the molecule has changed, and a signal is on its way down a nerve. That is a transition from one state of affairs to another, and it is the only moment in the entire history of that quantum where anything can be said to occur. Ask what physically happens at that moment, and you discover that this is the measurement problem, and that after a century, there is no agreed answer. The Copenhagen position is that the interaction constitutes a measurement. The wave function collapses. One outcome becomes actual, and the alternatives cease to exist. What collapse physically is, and what qualifies as a measurement, are questions the position does not answer, which is why Bell called that framework unprofessionally vague, and why a great many people have found it unsatisfying for 100 years. The Everett position is that nothing collapses. The wave function of the absorber becomes entangled with the wave function of the photon, the combined system evolves unitarily as it always does, and the branches decohere. All outcomes obtain. You are in one branch. The pilot wave position is that the particle always had a definite trajectory guided by a wave, and the appearance of collapse is our ignorance of the initial conditions. The transactional position is that a handshake has completed across the interval and the transaction is closed. These frameworks disagree about whether the wave function is a physical thing, whether outcomes are unique, whether the universe branches, and whether anything at all is random. They are not variations on a theme. They describe different worlds. And in 2021, Sean Carroll published an argument that pushes the discomfort one level further in a paper on energy conservation and non-conservation in quantum mechanics, pointing out that whether energy is conserved during a measurement is itself interpretation dependent. In the Copenhagen picture, a measurement can change the expectation value of the energy, which is a violation. In the Everett picture, it is conserved across the full wave function and only appears violated within a branch. The answer to what happens when the oldest light in the universe ends its existence inside your eye depends on which interpretation you hold, and the interpretations do not agree, and there is no experiment currently conceivable that distinguishes between them. Take stock of what that leaves us with. The photon has no proper time along its path. It has no position while in transit. It has no identity that persists. It loses almost all of its energy to an expansion that has nowhere to put it. And at the single moment where something demonstrably occurs, the discipline cannot tell you what occurred. There is exactly one thing about this entire object that physics states with total confidence and total unanimity. 0. The interval is 0. Everybody agrees. Every interpretation, every framework, every physicist, every textbook, for 117 years. The only unambiguous fact about light is the absence of duration, and that is the fact nobody discusses. I said earlier that this pattern would recur, and I want to name it plainly now, because we are close to the end and it deserves to be named. Alpha and Herman predicted the oldest light and were not cited. Minkowski gave physics its geometry and did not live 4 months past the lecture. Godel proved that the equations permit a universe with no objective passage of time, and Einstein's response was to hope the solution could be excluded on other grounds. Malament proved that causal structure determines almost the whole of spacetime geometry, and the result never left the technical literature. Global energy non-conservation is consensus physics and does not appear in public science at all. Bell wrote the most important theorem in the foundations of quantum mechanics on unpaid leave in a journal that folded and died the year he was nominated for the prize it eventually won. Every single one of those is a case where the physics was correct, was published, was accepted by the people qualified to judge it, and then went nowhere. Not because it was wrong. Because it did not fit the story that was already being told, and the story that was already being told was easier. That is 6. I have been counting. And the 7th is the one we have been building towards for the last 2 hours, and it is the largest, and it is the reason the 0 matters. Proper time requires rest mass. I put that in front of you near the beginning and asked you to hold it, And here is where it comes due. A clock is not a special kind of object. A clock is any physical system that reliably changes state at a regular rate, and you can build one out of almost anything. A pendulum, a quartz crystal, a cesium atom, a decaying nucleus, a biological cell dividing. What every one of those has in common is rest mass. Every clock that has ever been constructed or could ever be constructed is made of things that have a rest frame. Massless particles cannot be used. They have no rest frame in which to sit still and oscillate. They have no proper time along their own world line against which a rate could be defined. A photon has energy, momentum, polarization, and a null path. It does not have an internal state that evolves with respect to itself, because there is no with respect to itself, which means duration is not a property of the universe. It is a property of massive matter within the universe. Roger Penrose followed that observation to a conclusion that most physicists regard as speculative, and I am going to give it to you with that label attached, clearly, because it is the natural endpoint of everything in this script, and because I have not been able to find a flaw in the first half of the reasoning, even though I remain unconvinced by the second. Consider the far future. Not the future of the Sun, which has about 5 billion years before it becomes a red giant. Not the future of the galaxy, which will merge with Andromeda in roughly 4.5 billion. Go much further. Star formation continues for something on the order of 100 trillion years, and then the gas runs out and the last stars burn down. Galaxies gradually evaporate as gravitational encounters eject stars, over timescales of 10 to the 19 years or so. What is left falls into the central black holes, and then black holes evaporate. Hawking radiation is slow to the point of absurdity for anything large. A stellar mass black hole takes around 10 to the 67 years to evaporate completely. A supermassive one takes up to 10 to the 100 years. Write that number out and it means nothing, so here is a way to hold it. The current age of the universe is about 10 to the 10 years. If you compress the entire history of the universe so far, from the Big Bang through every star and every galaxy and every living thing that has ever existed, into a single second, then the evaporation of the last supermassive black hole would still be 10 to the 90 years away. The whole of history to date is not the first instant of that timescale. It is not measurable against it at all. Protons may decay too in some grand unified theories, though this has never been observed, and the experimental lower bound on the proton lifetime is already beyond 10 to the 34 years. Push far enough and you reach a state that Penrose describes with some care in his 2010 book Cycles of Time. Every black hole has evaporated. Every massive particle that can decay has decayed. What remains, spread across an enormously expanded and effectively empty spacetime, is radiation. Photons, gravitons, massless things. And Penrose's observation, which is the part I cannot dismiss, is this. In that universe, there is nothing left that can measure time. His exact words are worth having. It would appear, he writes, that rest mass is a necessary ingredient for the building of a clock, so if eventually there is little around that has any rest mass, the capacity for making measurements of the passage of time would be lost, and distances go with it, because distance measurement depends on time measurement. Later in the same argument he puts it more starkly. The universe itself, in the remote future, would somehow lose track of the scale of time. Not that there would be nobody left to measure it. That is the trivial reading, and it is not what he means. He means that the physical structure would no longer contain the information. Recall Malament. The causal structure gives you 9 of the 10 components of the metric, and the 10th, the one it cannot give you, is precisely the local scale. Scale is the piece that requires something with mass to define it. Remove all the mass, and the 10th component has nothing to fix it. the geometry becomes conformal. Sizes and durations stop having determinate values, not because we lack instruments, but because there is nothing in the physics that assigns them. Penrose then makes his speculative leap, and this is where the physics community largely parts company with him. If the far future has no scale, and the initial state of a Big Bang also had no scale in the relevant sense, because it was radiation-dominated and effectively massless too, then the two are conformally identical. The remote future of one universe can be smoothly glued to the beginning of the next. He calls this conformal cyclic cosmology, and he has spent years looking for signatures of previous aeons in the cosmic microwave background, and the claimed detections are disputed, and most cosmologists do not accept them. I do not know if conformal cyclic cosmology is right. I would guess not, and Penrose himself is careful to present it as a proposal rather than a result. But the first half of the argument does not depend on the second half at all. The first half is that time requires mass, and mass is a vanishing minority of what exists, and in the long run it goes away. And that is the seventh thing, and the largest, and the one that nobody says. Let me bring this all the way down to your body, because that is where it stops being cosmology. The sun emits on the order of 10 to the 40 5 photons every second. That is a rough figure, and it depends on what you assume about the average photon energy, but the order of magnitude is solid. Of that output, the Earth intercepts about 1 part in 2 billion, and of that, a vanishingly small share ends up entering the pupil of any particular person. The standard story about those photons is that they were made in the core by nuclear fusion and took somewhere between 10,000 and 170,000 years to work their way out through the radiative zone, bouncing around, before escaping the surface and crossing to Earth in 8 minutes and 20 seconds. That story needs one correction, and it is the same correction as the one about glass. The photon that leaves the surface of the sun is not the photon that was made in the core. There is a chain of absorptions and ray emissions, energy passing from quantum to quantum, degrading from gamma rays to visible light along the way. What takes 100,000 years is the energy transport. No individual quantum survives that journey. But look at what each link of that chain actually is. Every single hop, from the moment one photon is emitted by one nucleus or ion to the moment it is absorbed by the next, is a null path. 0 interval. No duration. The 100,000 years is entirely accounted for by the waiting time of the massive particles between hops. The light contributes nothing to the clock. So the sunlight on your face this morning is the terminal link in a chain of billions of zero-duration connections stretching back into the core of a star, and the total time recorded by the light along all of it, summed, is 0. The 100,000 years belongs to the plasma, not to the photons. And then there is the other light, the light you cannot see, which never had a chain at all. Roughly 29 million quanta of the cosmic microwave background occupy the volume of your body at every instant, passing through you unimpeded because your tissue is transparent at those wavelengths. Each one of them was last in contact with anything 13.8 billion years ago. At recombination, when the universe stopped being a plasma. Since that instant, nothing has happened to any of them. There has been no interaction, no scattering, no event of any kind. They have been continuously in the state they were left in. And now, they are inside you. The interval between the surface of last scattering and the interior of your chest cavity is 0. There is no elapsed time along that connection. The photon in your left lung right now and the primordial plasma that released it are, along the only path that connects them, in contact. 13.8 billion years of coordinate time separate those two events for everything with mass. For the thing that actually spans the gap, there is no gap. You are not looking at the early universe. you are not receiving a message from it. You are, in the strictest geometric sense the physics permits, touching it, continuously, everywhere on your body, and you have never felt a thing. Now widen it once more. Everything that has ever happened to you happened because you have mass. Every memory you have is a physical change in a structure made of massive particles. Every second you have experienced as a second was measured by chemistry, by oscillating molecules, by cells dividing, by the specific rate at which a proper time accumulates along the world line of a body with rest mass. Your experience of duration is not a window onto a universal flow. It is a local readout of a quantity that exists for you because you are heavy. And you are, by count, part of 1.6 billionth of what exists. For the other 1.6 billionth minus 1, for the overwhelming and near total majority of the contents of the universe, nothing has ever happened. There is no history. There is no before and after. There is no sequence of events. There is a set of null connections, each one recording 0, threaded through a geometry that those connections themselves define. The universe is not a place where things happen. The universe is a structure of timeless relations with a trace contamination of heavy matter, and the heavy matter is the only part that has anything resembling a story, and it is a rounding error. I said at the start that something clearly happened between that star dying and that light landing in a human eye. 7.5 billion years of it. Galaxies, planets, chemistry, life, a satellite in orbit above New Jersey catching gamma rays. All of that is what the rounding error did while the universe was not counting. There is a way of taking this that I want to warn you off, because I went there first and it is wrong. The mystical reading. The one where the timelessness of light means everything is one, the universe is consciousness. All moments are eternally present in some warm and reassuring sense. That reading is available, and it is popular, and it is not what any of this says. There is nothing in Minkowski geometry that is on your side. The interval is a number computed from a metric. It does not care about you, and it is not trying to tell you anything. The other wrong reading is the nihilistic one, where none of it matters, because time is an illusion. That does not follow either. Your proper time is entirely real. It is the most real thing there is about you, in the specific sense that it is an invariant calculated along your world line, and every observer in the universe will agree on how much of it you had. What relativity removes is the idea that your accumulated duration is a slice of some universal quantity. It is not. It is yours. That is not less than what you thought you had. It is a different thing than what you thought you had. What I cannot get past is narrower and stranger than either of those. It is that the universe appears to have two categories of thing in it. There is the framework, which is built from relations of zero interval, which has no duration in it anywhere, which determines 9/10 of the geometry by itself, and which comprises, by count, essentially everything. And there is the content. Heavy, slow, local, temporary, capable of accumulating proper time, capable of building clocks, capable of remembering, capable of asking questions about the framework. One part in 1.6 billion. We are the content. And the content is the only part of the universe for which anything is ever the case at a particular moment, which raises a question I do not have an answer to, and I have looked. Is the passage of time a discovery we made about the universe, or is it a description of what it is like to be a small, heavy thing embedded in a structure that does not have it? Every experiment, every measurement, every clock, everything we know about physics was produced by objects with rest mass. Our entire epistemic access to the universe runs through the one part of it that ages. We have no data of any kind from the other part, because the other part does not have states that could carry data about its own history, because it does not have a history. The largest sample in existence, 1.6 billion to 1, is silent. And Penrose's far future, whatever you think about the cyclic part, describes the endpoint. Star formation ends. Galaxies evaporate. Black holes radiate away over 10 to the 100 years. Massive particles decay or disperse until the density of anything that has a rest frame goes effectively to zero. And when the last thing that could tick stops ticking, the 10th component of the metric loses the thing that was fixing it. The scale goes undetermined, not unmeasured. Undetermined, there is no fact of the matter about how long a second is, because a second was always a relationship between massive things, and there are no massive things left. The framework remains. The null relations remain. The causal order that determines 9/10 of everything remains exactly as it was, because it never contained duration in the first place and has nothing to lose. The universe does not end in heat death. It ends in something more specific than that. It ends by shedding the only part of itself that was ever able to tell that anything was happening. And the light does not notice, because it never noticed anything. Go back to March 19th, 2008, and to whoever it was who happened to be outside that morning, dark adapted, looking at Boötes, and saw a faint point of light that had not been there before and was gone in under a minute. We do not know who they were. Several wide-field camera systems recorded the burst, and human beings certainly saw it, and no name is attached to the event. Whoever they were looking at the inside of a star that had died before the Earth existed. A quantum of the electromagnetic field left that collapsing core, crossed 40% of the age of the universe. Arrived at a planet that had assembled itself out of unrelated debris in the intervening time, entered an eye, and was absorbed by a single molecule which changed shape and fired a nerve. Between the star and the molecule, along the path that connected them, the elapsed time was 0. The star and the eye were touching. And every clock in the universe, including the one running in that person's chest, insisted that 7.5 billion years had passed, and every one of those clocks was correct, and the light that crossed the gap has no record of any of it. The interval is 0. It was always 0. It is 0 right now between the surface of last scattering and the 29 million quanta inside your body, and it is 0 between the core of the sun and your skin, and it will be 0 between every emission and every absorption for as long as there is anything left with mass to notice the difference. Nothing is happening. Nothing has ever happened. There is a 4-dimensional structure knitted together out of relations that record no duration, and inside it, briefly, in a quantity too small to matter. There is matter, and the matter is the part that has to feel it. You are that part. That is what the 0 means.